Hi, welcome to a presentation on PTP, or the Precision Timing Protocol, the need for timing and synchronization in data centers. My name is Anand Ram from Calnex. We're going to start by looking at the requirement or the need for timing in data centers. Timing is required by data centers driven by the requirement for data in these data centers to be decentralized. They need to be decentralized because there's a global demand for that data. But also importantly, this decentralized database needs to be correlated with respect to time. Why? Because an update made in Brazil needs to be correlated with an update made in Singapore. This update, the databases need to know whether this update is newer or older. So it needs correlation to a single source of time. Also, more accurate synchronization between these databases means more efficiency. For example, correlation to a millisecond rather than 10 milliseconds will mean less uncertainty in the date of that data. It means less correction, less rewrite, and definitely less transport of the bulk data. So milliseconds correlation globally is the target that global cloud operators have been shooting for. If we don't have accurate synchronization globally with data centers, we get incorrect data order in terms of timestamping. So this could lead to problems like incorrect billing, disputes between in financial or other trading environments. For example, we've given the example of fake news here, and that's an extreme example. But also remember, we said it's about efficiency. If you have a good correlation, there's a less requirement to transport data, and bulk transport of data needs money. So there is a strong demand for accurate correlation and synchronization of data in databases across data centers around the world. And this is really achieved by synchronization of time. There's another driver for timing and synchronization in data centers, and that's the financial trading space. So MiFID II is a financial directive regulatory recommendation that's come into play recently, and other countries and other regulators will follow suit. This mandates that the financial transactions need to be accurately timestamped in order for regulatory enforcement. Now, if you have more accurate synchronization delivered from the data center network, this has two benefits. One, you have more budget for timing inaccuracies in the processes and software, which means you could potentially deliver lower cost designs. Of course, having validated and certified synchronization specs can also be used when regulators query the accuracy of synchronization and timestamping in that financial trading network. The consequences of poor sync, of course, the inability to prove that the data set have accurate timestamps associated with it, and potentially large fines from regulators. As a data center equipment vendor, therefore, given the financial implications of synchronization, more specifically the accuracy of that synchronization, the PTP synchronization specifications of your data center equipment, that's your competitive advantage. So you could be building top-of-rack switches, core switches, any switch in that data center environment, or even the interconnects, the aggregators, or the network interface cards on the server racks. All of that equipment carries PTP synchronization, and the better your sync specs, the better your performance, and the more attractive your product. As a data center operator, you can also use this as a basis for selecting between different equipment vendors. Let's look at timing distribution exists in a data center. So this is an example data center network where we've got connectivity of a bunch of server racks here, and these blade servers are connected up via a series of leaf and spine switches. Timing can be distributed either via GPS or any other GNSS system through a GPS signal or GNSS signal distributed through a distribution infrastructure. But also a lot of data centers have then got a PTP as a backup, so you could either be getting GPS or a national time service coming in to a dedicated external grandmaster, which would then be using PTP to distribute time across that network. So this is a dual PTP and GNSS timing distribution. And remember, because this is a national time service, or in fact an international time service, because they're correlated, and GPS or GNSS is a global time signal, this means that the data here is correlated to other data sets in other data centers, as well as being correlated within the data center itself. The other option is simply to use PTP alone, but the dual model requires that the spine and leaf switches act as what we call boundary clocks, or BCs for the PTP, and then the server network interface card on the blade system is actually a PTP slave that recovers the time. The pure PTP model simply has GNSS coming into a grandmaster, and the grandmaster could be integrated into the switch, which is then distributed using PTP through the data center. And in this case, one of the spine switches or more is at grandmaster. Then the other switches are boundary clocks, which distribute the PTP time. And then again, the server network interface card is the slave. So how do we go about testing the performance and functionality? Remember, we said that the specifications and the performance of each of these devices is a competitive advantage for an equipment vendor, and it's also for the data center operator a basis of selection between these switch vendors. So the way to test it really is to test what's called the time error performance of PTP. And that's where the solutions from Calnex come in. Now, before we test the time error, we first need to verify that the protocol PTP is working correctly. There's a tool from Calnex called PFV, or the Protocol Field Verifier, which very quickly identifies protocol compliances or deviations from the standards. And this produces reports. We can generate a report that shows you any pass or fail according to the protocol. Now, if the protocol conforms, then you can go in and check the clock performance. And checking the clock performance to nanoseconds is a complicated affair. If you are making a switch or testing a switch, here it is in the middle here. In order to test its performance, you need multiple components around it to test, in this case, a boundary clock's performance for what's called time error. You're doing this, remember, to prove the PTP time error performance. Now, this is a complex, expensive, and importantly, error-prone setup. It's complex to set up. It takes a lot of time to set up, and the repeatability is the problem because every time you run the test, you get a different result. Ultimately, if we can integrate that whole test bed into the Calnex test solutions, that's what we've attempted to do with here the Paragon X product, which runs testing of boundary clocks to PTP conformance and clock specifications. So all of the sources of uncertainty within that test bed, which are primarily the pieces of equipment that are required to run the test, all of the cabling that's required to run the test, is all integrated into a single platform from Calnex, and you can then connect up to your system under test, be it a grandmaster or a boundary clock, and run those performance tests and make what we call time error performance. Of course, this is fast to set up, it's convenient, it's integrated, but most importantly, it's highly repeatable and reliable to nanoseconds accuracy. Ultimately, what you're measuring is time error of the device. And remember, the time error allows you to prove that a device operates under different conditions. The time error is of nanoseconds, tens of nanoseconds, hundreds of nanoseconds, or tens of microseconds, whatever the level you're looking for. And because the tester can operate to nanoseconds level precision, you can actually make the measurement to that same precision. And when you make that measurement, you get a result that is, for a vendor, the competitive advantage, or for a consumer of those vendors' products, the ability to evaluate between different vendors' products. Now, you can also go into a data center environment and make a measurement. So once it's deployed, you can use a portable tool from Calnex called Sentinel to measure the PTP and the timing performance inside the data center. Now, that's useful because it allows you to measure what the performance is in the data center. But it's also useful because that measurement can then be sent to your vendor to replay back in the lab. And when they replay it back in the lab, they're then able to test the performance of the device under test under the actual network profile conditions. And that allows them to then change or fine-tune the algorithms to overcome and troubleshoot any issues that may be there. So just a quick summary, timing is required in data centers for two reasons. One is to correlate data globally. Secondly, is for regulatory purposes in environments such as financial trading. Second point, the performance of the switches and the infrastructure in that data center network determine how accurate the synchronization is distributed within that data center. And so it is important to measure the accuracy of the timing or PTP elements within that data center. And the Calnex products provide a one-stop shop to allow you to measure the accuracy to nanoseconds precision. The Paragon X that we've shown you and the Sentinel are part of a portfolio of products from Calnex that are targeted at testing and verifying timing and network performance across different industries. Thank you for listening to the presentation.